in case in the future you may also need informations on composite propellers, so I'll not go through this thing, but you can just pause the video and read yourself. Alright. Okay, I think this is it. After reading, I should also actually so-called evaluate or elaborate on more things. Is that the composite molding is a little bit more expensive, alright, because although it's accurate and repeatable, or because it's more on the molding part, alright, but it's at a greater expense because of the manufacturing tool, alright. Then a SEM molding. SEM molding is for casting of a metal. So if you have a metal propeller, SEM molding is usually used, but it's generally lower cost than your so-called composite, and therefore this is why often they actually use compression or resin transfer molding to mold your propeller for your composite. Alright, for composite material, it is recommended you use the resin transfer molding. Resin transfer molding means that you have your mold over here with a certain shape already. Alright, then you set a tip over here, and then you have a few resin type of things, and then you tap into the pipes. So you send all the materials into this thing, and then you form this type of shape. Then once you cure it, you take it out, you have the propeller straight away. Alright, and therefore these are the benefits of all this. Quick process, good for large component, things like that. You should take note of it lah. Repeatable results, yeah, and it's more focusing on the accuracy. Alright, accuracy and repeatability, alright, for this type of manufacturing. So RTM is a resin transfer molding, if happen that you don't know what the hell, so now I know. Okay, and you should know this thing. In order to achieve high quality molding of the resin transfer molding, alright, you will take note of the fiber volume fraction. It will affect your things. So how it affects is that if you have a higher volume fraction of your fiber, you will have a low permeability and reduced ability of the resin to permeate through the fiber pack. Alright, so because if you have a lot of fiber that is very very near each other, the amount of resin flowing through is very hard. So if the more you pack it out, the more the resin cannot flow through it, and this gives you a very inconsistent material, alright, because the resin can't fill in properly, alright, and therefore it reduces your consistency of the laminate quality, as I've mentioned. And these are the things you should take note. So crucial parameters, alright, accurate tooling, careful loading of fiber. So you need to pick the loadings that you would need, alright, and I leave you to think about it for this one. And also the resin viscosity, alright, because it's talk about how the resin will flow through the cavity. Alright, the faster it flows, the better, right? It increases your time. But however, cannot too fast, because too fast, maybe you have some bubbles or don't know what the hell going on, like just anyhow bomb. But the faster you are, yeah, you have to control lah. Alright, so the viscosity, and you should allow it to be low enough, low viscosity, alright, to allow the resin to permeate the fiber pack, so it flow through the fiber. Alright, so I think the slower it is, the better. The low viscosity. Oh, okay. So low viscosity, I think is like water like that. Alright. This is a very clear picture of low and high viscosity. I no need to explain. So low is a water type of material. Alright. I mean water type of viscosity. And most epoxies by heating to between 40 degrees and 50 degrees. So in order to have a high volume fraction of laminate appropriate with a appropriate viscosity, this is the temperature that you will suggest. Okay, so take note of that. And with this type of temperature and configuration, it is also significantly quicker than normal system. Alright, that will be achieved using same resin at room temperature. So you want to elevate your temperature to this one, alright, with a certain appropriate viscosity, alright, so that it helps you to that. So fiber plies and the ply drop off, this word is also something new. So I actually look it up and it's actually this one. So your laminate, you have certain curvature, right? This type of thing. So this over here is causing the drop off. As you can see, there is this gap over here. So this is the ply drop off, I believe. Okay, and it's quite important. So I think I just write it down. Actually, they are defined by the mole dimensions. All right. So the mole is the resin transfer molding, that mole, and if either the mole does not close to the same position each time it is used, or the plies are out of position, large changes in the fiber volume fractions can occur. So if the mole is not close to the same position each time it is used, or maybe if the mole, good question, or the plies are out of position, so you need to arrange your mole in a good position in your ply. But your mole is your mole, I don't know lah, leave you to think about it lah. So ensure that your volume fraction is important, okay? Your fiber volume fraction, because inconsistency, a large fiber volume fraction will cause inconsistency in the material, which is not good. So therefore, take a thing of that. So a small error in loading fibers can lead to a change in local fiber volume fraction, and mean dry patch are left. So there is some dry patch. I don't know what's the dry patch also. One thing is that they actually recommend using a fiber weave style, so you can assist this type of processes on fabrics that maintain small channels under the pressure of the between the fibers, increase the reliability of the manufacture. No lah. Then wow, it's quite heavy this part. I think you can read yourself. It talks about preforming. Preforming, I think, is you do something before you preform. What the hell? I remember. Okay, so it's to determine the shape of or form beforehand. Alright, an object that has been subject to preliminary shaping. So you have to shape it first. So the preforming is to shape it first. That's the meaning of that. Okay, and let's get back to here. So your mold is assisted by a preforming, so you shape it to whatever shape that you want with a thermoplastic binder. Alright, so I think thermoplastic means that this material can be changed with heat. Alright, and it's a binder, so I think it binds the shape up so that it allows accurate placement. I think that is what it's trying to say. And and the volume fraction is about 50%, and so far manganese bronze boss has been molded. This is to enable a reliable retrofit of the propeller to the boat. So I think these are the things that he's trying to say. I don't know what's the boss. So I say half lah. So this one over here is your mold in the side view. Okay, so your side view. So you have this mold, and then you put in your propeller. Okay, you put in your propeller, and then you cover it. Well, actually it should be half lah. So this is what it's trying to say over here lah. So this is your propeller. So you feed in your resin, alright. So you feed in your resin through all these holes. Alright, it's a resin transfer molding. So once you feed in already, and overlap fabric, I don't know what the hell, and leading edge. So I think you have another extra parts for the leading edge over here at this part. So I think they will stick it over here. I think lah. Okay. So all in all, I think these are the stuff that you may want to know. So I think it's in the circular shape, the part more fabric. I don't know what the fuck, but yeah. But I'll leave you to think about it. So the takeaway over here, I believe, is the resin transfer molding for your propeller. Alright, and another one is volume fraction of fiber has to be controlled to allow consistency of the resin flow, as we have discussed just now. Okay, and the temperature also. Alright, the heating temperature is set to 40 degrees and 50 degrees. Alright, so that you can achieve quicker processes. So low viscosity of the resin, low viscosity means like water, so you flow very good, so that you can permeate through the fibers and for better consistency throughout the whole laminate of your propeller or whatever. So therefore I think these are all the things that you want to take note of, and I think this is it. You can read yourself later on, whatever lah. So yeah.